So as you can see in the picture, we are first going to define distance and displacement. Distance is the length of the actual path traveled by an object in motion while going from one point to another, and displacement is the minimum distance between the starting and the finishing point. We have discussed this in the earlier class also. So distance is covering the path from one point to another, and displacement in short means the actual path covered by an object from the starting point to finishing point. Coming to the use your brain part, you can see two diagrams A and B. The first example they are giving, I'll read. Every morning Swarali walks around the edge of a circular path having a radius of 100 meters as shown in the figure 1.2a. If she starts from point A and takes one round, how much distance has she walked and what is the displacement? So since it's a circular path, we know that circular path will have a circle. So circumference of the circle would be the distance covered by that particular girl Swarali. Whereas displacement would be what? She'll start from point A and again she will come to the point A back. That means since she is coming to the same point again, I can say the displacement is 0. So whenever there is a circular motion, displacement is going to be 0 because the object is coming to the original point. Second example, if a car is starting from point P, goes to point Q and then returns to point P, how much is the distance traveled and what is the displacement? Now the car is at point P, it's going to Q, so distance is 360 meters, and again the car is going back from point Q to P again, so again 360 meters, so total becomes 720 meters. So distance traveled is 720 meters, but the car is coming back to its original point. That means the displacement is 0. So remember that circular path, if the object comes back to the original point, the displacement is going to be 0, and when a car moving in a straight line come back to its original position, displacement is going to be 0. Distance can be calculated in this case by adding up the total distance covered, but displacement in this case is going to be 0. So I hope this makes things very clear. So we are able to understand the term distance, we are able to understand the term displacement, and we are also able to understand what is what are the cases when displacement can be 0. It was very clear from example A and B. Okay. Now when we go ahead in the chapter, we are going to introduce to the two terms, that is called speed and velocity. So they are asking you question again here. First of all, what are vectors and scalars? And the second is which of the quantity, distance, speed and velocity, displacement are scalar and vector quantity. I will not explain this again because we have done this enough in 8th standard. So I will want you to write these answers and show me in the WhatsApp group what are vectors and what are scalars. And out of the distance, speed, velocity, time and displacement, which are the scalar quantities and which are the vector quantity. Coming to the blue box, which says there is a definition of the speed, the total distance traveled and the total time upon the total time required. So distance traveled upon time, or simply distance upon time, is meant by the speed of the object. Distance traveled in a particular direction of an object in a unit time is called velocity. But if I am considering the change in distance, or if I am considering the displacement of the object, so total displacement upon time is the velocity. So in the orange box we have introduced to one more term. Velocity is nothing but displacement upon time. So speed is distance upon time, velocity is change in distance, that is displacement upon time, or the shortest distance upon time. Always remember, in the green box they are given us something. The unit of speed and velocity are the same because both are measuring the distance upon time. In CGS system, that is CGS system, it is centimeter per second. Speed is related to distance while velocity is related to displacement. Very, very important. If motion is along a straight line, the value of speed and velocity are same. Otherwise, they can be different. So in a straight line, the value of speed and velocity is going to remain same. But if the direction changes, it's going to be different. Velocity is displacement that occurs in unit time. So velocity is displacement upon time. So I hope speed and displacement, two formulas, are very clear because we are going to use it in calculating the particular terms. So speed is total distance upon time, velocity is displacement upon time. Both are going to have a same unit because both are nothing but distance covered in centimeter or meter upon time taken in seconds or minutes. So both are going to have same units. In SI system, meter per second; in CGS system, centimeter per second. So just to revise, what is vectors? Vectors are those quantity which have direction as well as magnitude, and scalars are those quantity which have only directions. So when I talk about distance can be, I just have to measure it in the measurement, so it is a scalar quantity. Speed, I need to measure, it's a scalar quantity, but velocity has to be in a particular direction, so it's going to be a vector quantity. So similarly, you can find out time and displacement whether they are scalar or vector, and which will help you out in understanding the same. So as we go ahead in the chapter, we have one problem sum which we are going to discuss. As you can see, the picture has changed. Now what is given here is, in the first example what we have studied in the Prashant Sheetal and the distance between school and that one in the earlier class, they are telling us in the example straight line distance between house of Sheetal and Sangeeta is 500 meter. Between Sangeeta's house and school is 1200 meter. Also a straight line between Sheetal's house and school is 1300 meter. So they are given us some measurements of distance. Also they are telling us to calculate the total. They are also given the time to reach from Sheetal takes 5 minutes to reach Sangeeta's house and 24 minutes to reach the school. So if you remember the diagram, we can, based on that we can calculate this. Sheetal's speed along path A, distance upon time. Distance is 500 meters and time taken is 5 minutes. So it's 100 meters per minute. Sheetal's speed along path B. If she takes path B, the distance is 1200 meter and time is 24 minutes. So it comes down to 50 minutes 50 meters per minute. So total average speed would be how much? 1200 plus 500, that is 1700 upon 24 plus 5, that is 29 minutes. It comes in decimal, that is 58.6 meters per minute. So Sheetal's velocity would be how much? If I consider the displacement is 1300 meters and total time taken is 29 minutes. So Sheetal's velocity would be 44.83 meters per minute. So it's very clear, when I am measuring the speed, I just consider distance upon time. But when I am measuring the displacement, when I am measuring the velocity, I should be knowing the displacement, the shortest distance taken to reach that point upon the time taken. So Sheetal's speed is changing at path A and path B, but Sheetal's velocity is completely different based upon the displacement upon time, which is 1300 meters upon 29 meters, which comes down to 44.83 meters per minute. I hope this makes very clear. So till we meet next time, thank you so much. Enjoy your studies online.